Hi everyone, my name is Mathieu Woillez. I'm from UMR Decode, working at Ifremer in Plouzané. And today I'm going to talk about the regional infrastructure named FISHOWF. So we'll see all the acoustic monitoring done over the offshore wind farm integrated in a larger scale infrastructure. So this regional scale infrastructure have been developed within the FISHOWF project that started 1 year earlier than FISHOWF. The aim of this project was to track fish movement at a regional scale, and we aim to increase the number of transition sites in good ecological status in the English Channel. We wanted to identify the most important habitat for several fish species and assess the effect of anthropogenic habitats on these species. And all those new type of data occur with acoustic telemetry, see how they can facilitate ecosystem-based management. So what is a transition site? Is an habitat that is that lie in the interface of sea and land. So these are the shoreline, the estuaries, the coastal estuaries, and we will do our monitoring along those shores in the English Channel. We have been focused on 5 species. So we track pollock, European sea bass, spiny lobster, bluefin tuna, and sea bream. And we choose those species because we thought that it was an important component of the coastal ecosystem, but also important commercial species for fisheries. We initiate our monitoring on 7 pilot sites. So 3 along the southern coast of UK, 1 in Belgium, and 3 along the northern coast of France. Here are the network of acoustic receivers that have been that are present in the region. So in dark blue, these are the receivers from the FISHOWF network over the different pilot sites, and in light blue, these are other receivers that have been deployed at the same time. So as you can see, I mean the monitoring done in the offshore wind farm of Saint-Brieuc and Courseulles-sur-Mer are also part of this network. So the construction of the regional network was made with by organizing a meeting with different stakeholders. We met fishermen with the support of fishery committee to co-construct this regional network and define the position where the receiver could be placed. So there were a lot of discussion on how we can maintain this network together, and also how we can perform a tagging survey that would be efficient for all the type of species we wanted to track. So for the tagging, so we did 3 tagging surveys along the coast of France, and here are the main steps that we follow to do this tagging done. So we first catch the fish with the help of fishermen, then we store the fish on board of a fishing vessel, and then we do anesthesia to make the implantation of tag within the body, and then we wake up those fish, keep them a bit to let them the time to recover, and then we release the fish in the sea to let them free and do their life. For the spiny lobster, this is easier. We just need to glue the tag, so the acoustic tag on the shelf of the spiny lobster, and then we can release them. So here are a map that sum up all the tagging survey that was done within the FISHOWF project. So they were tagging of more than 500 sea bass, 137 spiny lobster, 150 pollock, 64 sea bream, 59 bluefin tuna. this happened all over the channel area. And all those fish had been tracked for several years. So here are some summary of detection we had for the species. So you see that we were 67% of the tag animal were detected at least once by the network. And this corresponds to a lot of detection. So for example, for the sea bass, we had more than about 4 million detection over the year of tracking. And this tag can last for many years, or multiple years. So we will continue our tracking or monitoring of those species and learn more about their movement. So here I will give you some insight of the detection we had for the different species and which species get detected over the FISHOWF, the wind farm that were monitored by FISHOWF. So we got first for sea bass, you got detection on all the pilot sites where actually tagging happens. And you got detection in Courseulles-sur-Mer, offshore wind farm, but also in Saint-Nazaire, which was an offshore wind farm that was far away from where the tagging took place, actually. For the bluefin tuna, you got mostly detection in the western part of the English Channel, and there was a lot of detection within the offshore wind farm of Saint-Brieuc. So we'll go dive into a closer scale within the offshore wind farm, first of Courseulles-sur-Mer, and see that many sea bass, 26 sea bass have been detected within this offshore wind farm, and mostly in the southern eastern part of the farm. For the detection seen in Saint-Nazaire wind farm, it was only one individual that had been detected during November 2022. And it was a really interesting detection because the fish was tagged actually in Perros-Guirec, which is in the northern Brittany in June. And it confirmed the migration pattern that we were able to evidence on the sea bass population on another project, where we were able to see that sea bass from the northern coast of Brittany were migrating down to the Bay of Biscay, thanks to a modeling approach. And this detection confirmed with data, ground truth data, that effectively such a migration pattern happens. For bluefin tuna, we can have a look to the detection that happened in the Saint-Brieuc wind farm. There was 9 tuna detected, and mostly in the northwest part of the wind farm, and for every receiver that had been deployed. And this detection are quite seasonal. They happen during mostly in July and January, and it happens several years in a row, 2 years in a row. For the other species that have been tracked by Fish and Tail, there was no detection within the offshore wind farm for pollack, spiny lobster, or sea bass. So the movement of those individuals were more restricted, and they didn't move to the wind farm. Here is a sum up of the regional movement of all those species that have been tracked by Fish and Tail. So you got spiny lobster that show mainly restricted movement. Then you have tuna in the opposite, which is the figure on the far right, that show long distance migration. So those the individuals that have been tagged in the Western Channel have been also detecting along the Iberian Peninsula until the Strait of Gibraltar. Seabus also show long-distance migration from the North Sea to the Channel, but also to, as we see, to the Bay of Biscay. And for Sea Bream and Pollack, the movement are more restricted, but they still happen. So here we got an acoustic telemetry network in the channel that is operational and can be used to track many other species. All this information gives new insight in the spatial ecology of the species, and those type of data can be used for management, to have a more ecosystem-based management that account for movement, habitat preference, and environment. So it can be used to marine spatial planning to help the development of usage at sea. But to be helpful or interesting, this monitoring need to last over many years. So we need to maintain this infrastructure and to get some insight about essential knowledge that can be used to protect this habitat, but also to exploit sustainably the fishery resources. Thanks a lot.